Welcome back to another important session of data transformation. In the last few videos, we have learned and understood different aspects of data transformation we perform when we use data analytic activities. Usually, most of the activities that we have conducted just transformed the view, means rather than showing complete data set, we try to observe whatever we try to create a view that displays our expected columns and our expected columns that satisfies the conditions that we put. Okay, so that is a type of data transformation. There is one more type of data transformation for your information, that is adding data and removing data from the data transformation and data set that is available. Means we are using in this examples, in this activity, for example, we are using New York flight data set, right? So in the data set, we can, if we create some variables, means some columns to that data set, and if we delete some variables, means some columns from the data set, it is also considered as data transformation. Let us start with adding few new variables to the data set. Okay, for that purpose, the most important function that we use is mutate function. Okay, for mutate function will help us to create new columns in the data set. Let us start understand the structure how of the mutate function and how we use it to add new columns to the data set. This is the example. This is the example of a mutate function where we are using flights dot underscore SML, which is a copy of the flights data set that we used in the last activities, and we are creating gain hours and gain per hour, these three new variables, and appending it to the our database. Okay, our data set. And if you see that these three data set columns are created using the existing columns of the data set, departure delay and arrival delay. The gain is calculated by subtract. It is a column that will be added to the data set, and the value of the gain will be calculated by using a mathematical expression where array delay will be when array delay will be subtracted from the departure delay. So it's a simple thing. And hours is another column that will be calculated by using the expression air time divided by 60. Next, gain per hour is calculated by using the gain value that is created, and it is divided by the hours value. So beautiful, right? So this is how we create calculated fields in Microsoft SQL or SQL. We will be having a calculated fields. When we use Excel also, we will be having some number of calculated fields. How we calculate? See, for example, there are number of days you worked for, and for each day I will be paying maybe 500 rupees. So number of days worked into 500 will gives you net monthly salary or daily wage. Okay, maybe let us make it daily wage. The daily wage, so how many hours you worked? 8 hours. Per hour I might be paying 100 rupees. So what happens? Per hour it is 100 rupees. So to each day, how many hours you worked? Day, 4 hours you work, and for each hour 100 rupees per hour, and the total value will be calculated value will be 4 into 100, that is 400. That is the money you generated because of your contribution to the organization. Understood? In the same way, we calculate these new columns. So if you see here, before mutating it, rather than using the flight function, a new data variable is created, and it is named as flights underscore SML. And it was decided that the data set, by using select function, flights, it wants data from year to day, comma, ends with delay, means the columns that ends with delay, and it includes distance column and it includes air column. Okay, let us try this and let us display first what this is going to generate. Okay, select slides. Now let me try it. Yeah, I can do it. Select function, select. What are, I want to know like what are the columns they are using. Select LIGHTS slides, year to day, comma, and with what is that? Delay. And with delay, then what is used? Distance and air time, comma, air underscore time. So these are the columns they are using. So you can see that these are the columns they are using. And what they are doing is that this result is there, right? This result is sent to a new variable that is called slides underscore SML. Okay, so what they are doing, it is they are sending it into slides underscore SML. So when we declare this, you can see here slides underscore SML variable is created. Okay, now let us display slides underscore SML. What it displays? Slides underscore SML. So it displays the same values that are displayed in the last step. So we have a variable with required number of columns and column values. Now we are supposed to add new columns. We want to create a new variable and we want to add it to the existing data set. Okay, let us try that one. We use mutate slides. What is the data set? Slides underscore SML. Slides underscore SML, comma, what is that one? First one is gain. Gain is equal to, so I guess we need to keep them in quotes. No, gain is equal to, just straight away, gain is equal to, what is that? Departure delay minus arrival delay. Departure underscore delay minus arrival underscore delay, comma, next one is R. R is equal to air time, air underscore time divided by 60. That is what it is defined there, right? Gain is defined. Oh my god, I want to do this one. Air time divided by 60. Okay, air time divided by 60, that is done. Next one is gain per hour is equal to gain by hour. Gain underscore per underscore hour. Is that? Yeah, is equal to, like here we have gain and divided by hour. Gain divided by hour. Let us try this. Done. You can see that the values are displayed here. Gain is displayed, hours is displayed. This divided by this, which is gain per hour, is also displayed. So this is how we can create and we can add new mutants to the data set. Now, if you try to display slides underscore SML, it will be displaying the result that is displayed now, as it got added with 3 new columns. Understood? So let us try display slides underscore SML. Okay, sorry. Oh my god. Chalo. So slides mutate will be displaying those 3 things. Got confused. Okay. So let us try in that way. So slides underscore this SML will be the same, and if you want to see those calculated values, we might be displaying it separately. Okay. So this is how it happens, and we have all the data. Next, what we do is, it's a mistake, ignore it. Chalo, next one is, after that one we got transmitted. What they are trying to do, if you want to keep the new variable, that's what we call transmitted. When we use this one, it keeps value. Okay, it was my mistake, I got confused. Now if you use this one, same function, sorry, so rather than using mutate, if you use transmitted, okay, I'm using trans, when we use transmute, trans, transmute and the function, what happens? Let us see. Slides.html. If you only want to keep the new variables, use transmuted. So when we are using this one, what happening? What is happening? It only keeps the calculated values. Again, mistake. So actually, I do remember if mute, that update function, I guess, and we need to maybe update it with the new values. Okay, append. I need to append it. So that's it. We did transmute and both the things. Then these are the some of the parameters, that some of the operators that you can use to create values. Got it, guys? So plus, minus, into, multiplication, arithmetic operators you can use, and you can use a modular arithmetic, that is modular, and you can create a calculator field. Okay, this is for the purpose of creating new columns. See, we can try all these examples. Okay, after this one, we can use log function. See, we got x variable that contains values from 1 to 10, and you can calculate log of x and the lead of x. Okay, log of 1, log of 2, log of 3, log of 10. Log of 10 is 1, and remaining all values it won't apply. Lead of x. Sorry guys, I missed it. So let me try it again. So when we use x goes 1 to 10, so I'm sending values from 1 to 10 into the x. It contains values of 1 to 10. When I press enter, x and enter, it shows that the value contains 1 to 10. Log of x. So we have, for each value, log value is calculated. So these are some basic functions. It means that we can use, in this way we can use it. So for example, if departure delay is log of arrival delay, means you can calculate it. Like how you can calculate it, departure delay is equal to new one. L departure delay is equal to log of departure delay. In that way you can calculate. So it means that you can use log function to calculate a new value. Like again, you can use lead to calculate new one. You can use cumulative sum of values and cumulative mean of values. You can use all these activities. Just try it. That's it. So you can very easy things, and every time I need to rechange it. That's why I'm not mentioning all the activities. All the actions are not shown here. So just cross check. You try them. So for example, row number of y. So this is the interesting one. Dense rank of y, and it will be displaying. Okay. So percent rank of y. So you got a y value, and it will be displaying the percentage value of it. Okay, cumulative distribution of y. So these are basic functions, you can understand. So you got percentile also, entire, and dense rank, row number. There are many different things that you can use. Okay, so let me try with 5.52 exercises. 5.51 is also there. I don't know. Let me check it. 5.52 exercises. What about 5.51? Let me check. So 5.51 is activity, useful creation functions activity, and 5.2 is actual exercise. Okay. In that we got I guess 3 questions to address. We got 2, 4, 5 to address. So I will be showing only 2, 4, 5 solutions. Remaining all you need to try it. Okay. So let me check the question. Compare 8 time with 8 time minus departure. What do you expect to see? What do you need to do to fix it? So let us try with this function mutate flight comma, and I will be calculating 8 time minus departure time as it was asked in the requirement task. Okay, so let me check. 3 point, no, 3.5 that exercises. Here it is asked to compare these two values, departure time and, sorry, second one. We need to compare these two values, air time and air time minus departure time. So we need to calculate this first. Then we need to compare the value that we achieved with air time. To calculate this, we wrote this command, right? Mutate flight, and flight time is equal to, I'm creating a variable by name flight time, and it is calculated by subtracting departure time from arrival time. So let me click this displays this information. So the output shows the value. Let me move this information to a new variable. Okay. So again, FLI underscore FLI underscore SAM1. దీనిలో పంపిద్దాం. Okay, SAM1. So I'm just moved it into this one. So FLI underscore SAM. It displays all the values. Now let us select. See, FLI SAM can be your, like, you can use any name. That is just variable name. You can use any name for that. Okay. So you, like, what I mean is, rather than using FLI SAM1, I can use Avina underscore sample. So I can use this one, and I can use Avina sample to display it. So simple. Whatever you like, you can use. Now I select values. SELUCT select from dataset my FLI SAM1, comma. What are the two values that I need to compare? The first value is air time, air underscore time, comma, and the calculated value, that is FLT underscore time. Here FLT underscore time is also a variable. You can give any name to that. Okay, just for my convenience, I am giving FLT underscore time. So let me display it. I can see that there are two values that are displayed here, air time and FLT time. Okay, this can be done in many other ways. So this is the simple way that we know, right? So I'm trying to display it. I'm displaying these two values just to compare with each other. If you check this one, air time is, if we understand the data set, we know that air time is the total time or the total minutes for which the flight is in air or like on air. Okay, so that is what we call air time. And whereas arrival time and departure time, which is not a continuous time, it is just the time when the flight has come, and the departure time is when the flight is left. Okay, there is a lot of difference between these two things. It is a difference between total minutes the flight is in air, and we cannot compare it with the time that we see in watch. So that is means at 6 o'clock, 7 o'clock it arrives. We cannot compare these two things. So what we need to do is to compare these two things. What we do is we try to transform existing data into that particular the form, at least one or the other form. If you want to convert it into minutes, you can convert it into minutes. Otherwise, if you want to convert it into time, you should convert air time into the time. Okay, these are the two options. You need to keep both the values. For example, you cannot compare 20 with a name of a person. Okay, these two are two different things. One is of type number, another is of type string. Okay, so you cannot compare these two things. To compare these two things, what you should do, at least you should transform value 10 to TEN10, where it becomes text value, and you can compare text value of 10 with the value or person of some particular name. So this is how we do. So when we try to compare, both the values, both the variables should be of same type. So what we try here is, so by this we can see that one value is continuous and continuous value, and another value is just time value. Okay, so what we do is we will be transforming the flight time into continuous value. Now we got a formula to mutate it. See, what I'm trying to do is like 8 time is converted into minutes, total minutes. For that I am dividing it by 100 and multiplying it with, so that is in 100, 600 minutes divided by 100 into 60, which will be giving value of minutes plus arrival time modulo 10. Okay, so let me try using this one, and what is the value I'm going to get? I get some value for that. What I do is like the same way I will try to send it to flight SAM1, FLI SAM1, SAM1 goes. I'm sending the output into the same old variable. Okay, I did that. Fly SAM1. Okay, same variable. I sent it. Next, what I do is departure time, arrival time, departure time minute, and departure time. Okay, I'm adding one more variable. Okay, now SLI fly SAM1 empty variable. Okay, FLI SAM1 entered. I displayed all the variables. That's it. Time in. Now it should show 22 variables. It doesn't have the column. Oh, got it. So here it is fly SAM1. It should be fly SAM1. Fly SAM1. So when I'm using flights again, it is using old flight data set, and that does not contain the past value, right? So it is displaying the error fly SAM1 does not contain fly SAM1. It is SAM1. Oh my God, sorry, too many errors, guys. So this is the data, and for this, what I do, fly SAM1, 8 Okay, FLI SAM1. Let me try this. It contains arrival time fly SAM1. Now let me try with departure time min and departure time and departure time. So now it displays both the values. So now it contains departure time means and departure time means. What happened is here when I'm trying to create two different values and I want to mutate them and I want to append them to the fly SAM1. So first what I did is I used flights for creating air and again I used flights for creating departures. So when I use this one, what happens is flights will be appending one value and it will be sent it to this one. Again into the SAM1, this one will be gone like because we are not using fly SAM1 here, we are using flights again. So what happens is this cannot be displayed. Again new value is created to this one. So to avoid that, what I did is at first I will be using the flight, and the next time when I use it, I will be using fly SAM1 here to ensure that the data that is created will go into fly SAM1, and when I use that one, that data will be existing, and when I create a new mutant, it will be added to this, and it shows both the values at the end of the data set. I got both the values. Now I will be comparing these two values with A time. So let us display it. Mutant fly SAM1. No, let's say transmit. It will be helpful. Okay. Transmute fly SAM1, comma. No, let's do same functionality. Fly SAM1. The 10th FLI time. I use FLI time. FLI TIME time is equal to ARR underscore time underscore min minus DEP underscore time underscore min. So now I am executing arrival time and departure time. FLI input FLI time min. Now it works. So now select a FLI SAM 1 comma FLI time comma air time. So now it is displaying two different values. Now you can check that these values are somewhere near to each other when compared to the comparisons that we made at earlier. It is 227 and 313, 227 and 313. That is the difference is very large, and this one is now whatever the result we achieved, 227 and 193, 227 and 197. These are very near to each other. Okay, this is how we compare two different data types. We transform it into the like both the fields to be maintain a common type of data, and then we try to compare each other. Okay, when we cross check these things, most of the times A time is greater than FLI time, and there are few occasions where FLI time is greater than A time. Okay, this is how we conduct activity. Right, guys. So what I want you to do is I want you to use some of the activities. Mm, I want a screenshot of some of the activities. So what we do again, let us conduct fresh activity. Control L. What we need to do? So we need to calculate arrival time minus departure time first. So let us calculate it. Mutate flight, comma ARR FLI time is equal to ARR underscore time minus DP underscore time. This is the first step that we do. We get some values. Okay. Then as it is not possible for us to show it, what I do is I will take temp. Temp takes values of the above function. Temp takes values of the result. So it goes the result. Temp displays the value. Okay, so what I did, you can give your own name. First step, first step. Then the second step is sending values into mutate. Okay, you can directly start with second step. That's not a problem. This is for just to show like how we are working. So we need to know how the function is working, right? For that purpose. First, I learned how to create a new mutant, and what I did is when I created it, I appended it to the slide, and it is the result is sent to the temp. Okay, next I need to select aid time and FLI time. So let me try that one. SELECT select slide. It is from not slide. It is from temp, comma. What are the values do I need to send? AIR aid underscore time time, comma FLI time flight time. So it is showing both the values. We know that aid time is a continuous value which is calculated from 1 minute, 2 minutes, 3 minutes. In this way, it will be continuous, and it continuously counts the number of minutes the flight is in air, or like flight is on air. Okay. Next one is FLI time, which is calculated by subtracting two time variables. Okay. Actually, arrival time is it's a time notation, and departure time is it is also a time notation. So we cannot compare a continuous value with a time notation. So what we need to do, we need to transform time notation to minutes, like continuous value. So what we do, we have a formula for that, and we will be implementing formula to transform air time and departure time, both the values. Then we will be subtracting air time minus departure time. Then we try to compare it with air time. Okay, we will be transforming arrival time and departure time, and we will be subtracting departure time from arrival time. We calculate a field, and we calculate that value, and that value will be compared with the air time. Got it, guys? So let us start transforming. So I will be taking all the screenshots. So at least I will put this screenshot. So after running these three commands, I get this kind of output. So I'm taking that output, and this output is achieved. Now what I do is I will start explaining the difference between these two things. I say that A time is a continuous value and FLI time is a time value. See, you need to say that A time and departure time both are not continuous values. They are time values. Okay. So the subtraction of departure time from A time will give you a time value again, which is an inappropriate value. So you cannot compare these two values. That is the conclusion that we can make out of this thing. Next, what we do is, then what is the solution for that? For that, the solution is that we need to transform aid time and departure time to from time values to continuous values, and that continuous values are subtracted, and we create a value which we can compare with aid time. So that should be clearly explained here below this screenshot. Now, after the explanation, what I do, I will be transforming values. So if you check this, I'm transforming value and I'm sending it into FLI SAM1. Now this I will keep like FLI GH. Okay, transform the first one. Then FLI SAM, I will take SLI SAM1, and this is departure, and this is, I'm transforming both the values to continuous form. Departure time. Okay, now departure time. So I execute it. Now FLI SAM have both the values. Okay, now we have arrival time value and departure. Arrival time value and departure time value. That's great. What is the next step that we do? Next step is using mutant to create a new variable that subtracts. The field will be is formed by, is a calculation that we create by subtracting departure time means from arrival time. So mutate and mutant FLI TIM flight time. Sorry, you need to add data set name, right? FLI SAM. So use your own variable. Okay, don't use mine. FLI SAM1, comma, what is that? Flight time. FLI TIM flight time is equal to ARR underscore time underscore min minus DP underscore time underscore min. So this is definition. Oh my god. Mutate. So this mutate, and it got mutated. Now I will be sending this value to FLI SAM. FLI SAM1. Okay, I'm sending value into the same data set again. If you press FLI SAM1, you get the results, and in that you will be selecting A time and A time, A underscore time, comma, FLI TIM. Now you got the values that you can compare. That's it, guys. That is the activity of section 2. And I guess it's taking a lot of time, so I will make for these two questions, fourth question and the fifth question, I will make another video. Let me take screenshots of these things. Now what I did, this is done. What is the purpose of doing this? To transform data to continuous form. Okay, now after this, what I did, I created a mutant to include value of flight time. So I created this one, then I displayed the values to compare. Okay, so these are the 8 comments I regularly use if I am not explaining you people. Okay, this much is enough to generate an output that you can compare with each other. Okay, okay guys, hope you guys are understanding it. Even if you are not understanding, try to understand. Alright guys, I know you people are intelligent and you can grasp it easily. So please try to understand the topic. Now done. It's done with second activity. I need to add few sentences. I will add it on my own. So saying why you cannot compare it. This is simple. 3 or 4 sentences is enough to 3 or 4 sentences are enough to explain it. Alright guys, happy learning. Thank you. I will explain 5.5.2 exercises in next video. So 2 more exercises in the next video. Alright, thank you.